Here we are, video problem number 16. This is on orbital diagrams and electron configuration. Before we get into the actual problem, let's just quickly look over the periodic table and identify the different blocks. So groups 1 and 2, the alkali metals, the alkali earth metals, hydrogen and helium over here. Those are what are said to be the S block. And then we have groups 13 through 18 over here, a wide group of elements, and they are the P block. And then we have the transition metals here, some of the transition metals, not all of them. And this is the period -1 D block. And then down below here is the F block. And you know, they actually belong right here. I'll make a little line there. But again, this is the F block. Okay. And then we also have the periods. So they're labeled here, but period 1, 2, 3, 4, 5, 6, and period 7. So let's try these out. Give the complete electron configuration of the following elements. We start out with hydrogen. So let me pick a good color here. So here's hydrogen. So that is in the first period. It is in the S block. And there is only one electron in that S block, so it's 1s1. Beryllium right here, right? So we have to go through the first period, so we have to go hit that one and that one, hydrogen and helium. So the first two electrons go into the 1s2, that's the lowest energy. And then we have the second period, it's the S block, so we're right here again, second period, S block. So that's 2s2, because now there are two electrons in that 2s. Right? Carbon way over here. Right? So if we look at that, we have to go through the first period. So we have to go 1 and 2. Then we have to go through 2s, and then we end up at 2p. So that's going to be 1s2, 2s2, 2p2. So 6 electrons total. We have magnesium down here, so we have to go through the first, the second, and through 3s. So going through the first period is going to be 1s2, so there's the first period done. The second period is going to be 2s2, which gets me now to right here, and now I need to go all the way through the p's, so that's going to be 2p6, because there's 6 of them. 1, 2, 3, 4, 5, 6, and then we end up at the third period now, and that's S2, because there's 2 in the S, 3s2. Okay. The next one is argon, so here's argon right here, and so that's going to be, goes all the way through the third period. So 1s2, there's the first period, 2s2, 2p6, there's the second period, 3s2, 3p6, there's the third period. Alright. Now the next question is, give the abbreviated electron configuration of the same elements. This could also be the noble gas configuration. Okay. It's better to think of it as the abbreviated configuration because we're getting away from the idea that the noble gas is special. We don't like to use the term noble gas to explain things. I mean, noble gases are just fine, but to explain it because it's a noble gas is bad. So the abbreviated electron configuration, all it does, let me erase some stuff here for you real quick. So the abbreviated electron configuration just tells us the noble gas before the element. So hydrogen doesn't have an abbreviated electron configuration, so it is just 1s1. Then we get to beryllium. We can go to the noble gas before it. Not a lot of people use helium, but helium is the noble gas before beryllium. So here's beryllium. Right? Helium is the noble gas before it. So what we're going to do is we're going to put helium in brackets. So that means I've done the electron configuration of the helium, so I can just say it's 2s2. Okay. What's next? Next is carbon. So carbon is on the same period right there. So again, we're going to do helium, and that helium is the configuration of 1s2. It's going to be 2s2, 2p2. So again, helium takes the place of 1s2. So let's go to magnesium. So now magnesium is on that third period. So now the noble gas before magnesium is neon. So I got to do neon in brackets. Alright, and then it's going to be, what is it going to be? 3s2. So the neon stands for 1s2, 2s2, 2p6. And then we have argon, went argon. So argon again is on that third period, so we're going to use neon again. So that's the electron configuration of neon. It's going to be 3s2, 3p6. Okay, so there's the abbreviated electron configuration.